to get free ride.
Are you serious?
Yeah. I was gonna do it. I'm not gonna do it in the freaking winter.
I forgot he's like a pilot.
It's like, hey, just
All
remind
I
you.
can say is I'll keep you guys posted. You'll know
It's
what
like,
I know.
I'll let you know.
I mean, it's...
Chat on Facebook.
All right, so let's get started. We have spent the last 3 class periods, I think, talking about a lot of theory stuff, mostly in terms of algorithm analysis. We went over big O notation and what it means, and then we spent 2 days analyzing non-recursive algorithms. Non-recursive algorithms, you remember, those are ones that have loops in them, no recursion. What I want you to take away from that, big picture-wise, is the process for analyzing non-recursive algorithms. So step 1 is identify the input size. And the next thing you do is you look at the code and figure out what the basic operation is. Basic operation is the operation of line of code that contributes most to the total runtime. Okay, once you pick out the basic operation, then you set up a summation that expresses the number of times the basic operation runs. The bounds of the summation resemble or reflect the bounds of the for loop, or whatever looping operation it is. Once you have the summation solved, you're given the algorithm in functional notation. Pick out the dominant term, put the dominant term in big O notation. Okay, so that's what you need to be familiar with, that process. You need to be able to execute that on a relatively basic, like a single for loop type algorithm. Okay. But we are going to shift gears today and move away from kind of a theory approach to this, and we're going to get into, at this point, really the heart of what this course is, which is the data structures aspect. And so we are going to start looking at, from this point on, aside from a couple class periods where we break and look at recursion and how we analyze recursive algorithms, we are going to spend the rest of the time coding and looking at how to implement and use various data structures. Okay, so we're going to start today with our first data structure, which is a queue. And then at the end of today's class, I'm going to go over your first programming assignment. Because for your first programming assignment, you're going to be implementing a queue yourself. Okay, and I'll give you some guidelines as far as what you're going to be going through and doing, but I want to make sure that we're clear with the requirements and the expectations for your program. So we'll spend about 10 minutes at the end of class today going over that. Okay? So how today is going to work is this. I'm going to explain what queues are, how they work, when you use them, how you implement them, and then we're going to start writing a program from scratch that's going to implement a queue. So we're going to write a queue from scratch. We'll make it a little bit into the program, and then we're going to stop and end class with going over your programming assignment, and then next class we'll finish the program, whenever next class is. Okay.
Eventually.
I keep saying that. It'll happen. Okay. Any questions on that, on what we're doing? Okay. All right, so let's talk about this. So there's a topic outline. If you go into Canvas, you'll see there's a topic outline for linked lists, and there's one for stacks and queues. Okay, we're going to kind of do everything all together. All right, and so the materials that are posted on Canvas are good, but I'm going to present them in a little bit different way here, just for variety. All right, so the first thing I want to cover is what a queue is. Anyone who's played any online game or done just about anything online where you are waiting in a line, whether you're buying tickets on Ticketmaster or you're trying to log into a game or anything like that, familiar with the concept of a queue. In America, we call them lines, but in most other parts of the world, they're called queues. Okay, and a queue is just another word for a line. Okay? And so the queue data structure represents that. And the ordering, which is important here, is first in, first out. Typically abbreviated FIFO. And if you take business courses, you look at inventory management systems, you'll see these terms as well. Okay? First in, first out refers to the inventory that was brought in first is the first that you sell. So grocery stores do it this way. Otherwise, they end up with a bunch of spoiled food. Okay? And the idea here is, if you are in the queue first, you will leave before those that arrived after you. Okay? And this is what we normally expect. If you are waiting in line, here's someone selling coffee. Kind of looks like a snow cone. We'll make it snow cones. Not coffee, we're selling snow cones. If you get in line, I'll do
It's too
coffee.
cold for snow cone.
To buy a snow cone.
This is smart season. Some snow cone won't melt.
That's a person.
What's happened to his legs?
He hurt his leg. He wants a snow cone. Give him a break. Art is not my forte. You get in line to buy a snow cone, and then somebody else gets in line after you. They go behind you, right? The way most people get in lines. So when you go up to pay, who is the first person to leave? The green person or the red person? The green person. Okay, and we expect this. If somebody else gets in line, they don't skip, they don't go in the front, they don't go in the middle. It doesn't matter who's in the line already, you simply just go to the back of the line. This is a concept that we're all familiar with. It's how our society works. Okay? New objects get added to the back. Objects get removed from the front. Okay? That concept is wrapped up in this. Okay? New objects get added to the back objects get removed from the front. So the whole purpose of this course, and what we're doing when we're teaching you guys data structures, is we're teaching you different ways to manage the stuff that's in your programs. Okay, and we'll use objects as a generic term. Okay, whether you're keeping track of students or inventory or bullets in a video game, could be anything. The idea here is we're trying to keep track of stuff, and all that you guys really know right now, you know, single variables, you know, arrays, and you might have been taught array lists. But that's it. And there's lots of better ways to keep track of your stuff depending on the situation. Now, there's nothing wrong with arrays, and there's nothing wrong with array lists. You will still use those, and you'll use them frequently. But when we're talking about larger systems, or even specific systems that are perhaps smaller but operate in a unique way, there are better ways, more efficient ways to maintain and mess with those lists than just array list and arrays. Okay? So, when you have a situation in a program where you need to represent this type of behavior, a queue works well. Okay, you guys are probably too young to remember this, but back in the day with computers, you used to only be able to do one thing at a time. Okay, so your computer starts up, and you double-click to open Microsoft Word. Microsoft Word's opening up, and you're like, oh, I want to check something on the internet while Word is loading up, because it takes long. So you open up your browser, double-click on Internet Explorer, which is another thing you had back then. So they open it up, and all of the code for opening Internet Explorer, does that run right away? It does now, but it didn't back in the day. Okay? Because it all had to wait for a word to open. And now we've got multi-threading, multi-cores, and all that sort of thing. So you can do a bunch of stuff all at the same time. But it used to be a series of operations that executed in the order that you specify. A lot of operating system procedures are represented by queues. You say do this, and then do this, and then do this. There's a proper order that they happen. And the way this works is, instead of objects or people that we put into the queue, we're putting in commands or operations. So open Word, and then open Internet Explorer, and then do something else. Until this finishes, this one can't start operating. Okay, and until this finishes, this can't start. Conceptually, does this make sense on how a queue works? So new objects get added to the back, always, and objects get removed from the front, always. No exception. So this might beg the question, okay, well what if I have a situation where most of the time I add to the back, and most of the time I remove from the front, but every now and then I want to stick something in the middle. Don't use a queue. Okay. If the needs of your program and the functionality is different from these rules, then don't use a queue. There are other structures to use. Okay. What makes a queue good is the rigid rules for where you add and remove stuff. When you start messing with that, then you lose the benefit of what a queue is. And this will make more sense as we learn more data structures and we look at the complexity of the various operations. Okay? Now, last thing before we get into the next part. There are specific terms for adding and removing for a lot of data structures. Okay? So when we look at stacks and queues and heaps and binary search trees and all of these other different types of data structures, there are a lot of times specific terms that mean add to the structure, remove from the structure. Now, why they don't all just use add and remove, I don't know. Okay? But knowing these terms adds to your computer science literacy. So if somebody's talking about something like, yeah, we're going to push it onto the structure, and then we're going to do something with it, and then we'll pop it off. Those terms immediately identify what data structure they're talking about. Okay? And so it's important to be familiar with these terms. On top of that, when you are coding this, if you happen to pull in a pre-built data structure that the language offers, the names of the methods are going to be the specific terms. Okay, so if you go pull up a queue and you go queue.add, and there's no add method, that's because adding to a queue isn't called add. Okay, and so you need to know these terms. So adding to a queue is called enqueue. Enqueue. And removing is called dequeue. Like the ice cream sheet.
That's what we're talking about.
Yes. See? Subconscious. Questions on this? Good so far. It's easy, right? Makes sense? Right. I want to make sure we understand this first because it's getting ready to get really different in how we implement this. Yes, sir?
When you DQ, it goes from the top, right? It moves it in.
All right, good question. So let's look at how we visualize this. Because that's kind of what we're going into next. Now, here's the thing. This big picture concept that I want you to understand. All right? We're going to talk about this over and over and over again each time we talk about a new data structure. All right? And the idea that I want you to understand is a base data structure. Okay? A base data structure is an independently functioning that is used to implement a more advanced data structure. My marker's kind of dying. Hold on.
Miss.
No, it went in.
That's where the sounds come from.
No, that was somebody else that dropped something on the floor. It masked the sound of the marker landing in the trash can. You can look. You can look after class. So here's a concept. The more you learn, the more you'll be able to build more complex things. Okay? And the idea with this base data structure is this. We can take data structures that we can use by themselves, like an array or an array list. And we can use those independently functioning, because we can use an array and array list by itself, as is, or we can use those data structures as a base to build more complex ones. Okay? Example, we can use an array or an array list to build a queue. Okay? So if we have an array, here's our array. Add an object, it goes here. Add another object, it goes here. Add another object, it goes here. I go to remove it, which one gets removed? This one. I go to remove it again, this one goes. I add, goes back here. Add again, goes back here. I remove, this one goes. See how it works? But what we're going to do is we are going to implement a queue using a linked list. Okay? Linked lists are brand new. Anybody done linked lists before? Nobody. So, we are going to implement a queue using a linked list as the base data structure. Okay? So, we all know what a queue is. A queue is simply a data structure that has rules for where you add and where you remove. That's it. Okay? That's what makes a queue a queue. What we're going to use to implement a queue is not an index-based structure like an array or an array list where you access objects or elements of the array using an index number. We're going to build our queue using a linked list, which is a brand new data structure that we're going to use as the base data structure. Okay? So before we get coding, I'm going to briefly explain what a linked list is, and then we'll start coding this. Okay, everybody good? Okay. So linked lists are where it gets a little bit difficult. Because conceptually, they're very different from a lot of the stuff we've done so far. You guys remember at the beginning of the semester where we really looked in depth about how reference variables work and the fact that when you create an object, you have a reference variable that is one location of memory, and then you have the object in a different location in memory, and the reference variable simply holds the location in memory to where the object is. It refers to an object, just like a pointer in C++. You guys remember that? Okay. This is where that concept is going to become really important, okay, with how a linked list works. So, here's the idea with the linked list. First of all, it is not indexed. It is not an indexed list. So I'm going to say linked list. Now, here's how it works. We'll say this. First thing is the linked list itself keeps track of or keeps references to the first and the last object in the list. Kind of looks like this. So we've got first, which simply points to the first object in the list, and we have last, which points to or references the last object in the list. Okay? Good so far? So this is a reference variable, this is a reference variable, and they both point to the object, or both point to an object that's contained inside of the list. Now, the next characteristic of a linked list is each object in the list holds a reference to the next object in the list. Each object in the list holds a reference to the next object in the list. So the object that's first will hold a reference to the object that is second. The second object holds a reference to the third object. The third object holds a reference to the fourth object, and so on. Now, does this make sense so far? Conceptually, we good? We'll figure out the coding in just a little bit. But look at this last object. So if you're the last object in the list, what is your next reference?
The first.
Could be the first. So here's the thing. There are different types of linked lists. Okay, we're going to do a basic implementation, what is known as a singly linked list, where each object holds a single reference to the next one on the list. Okay? If the last holds a reference to the first, that's called a circular linked list. We'll get to that later. Okay? So, when we're talking about these references, remember, there are no index numbers. So, when we're talking about this, this isn't at position 0, like we would say if it were an array or an array list. We say it's first. It's the first one on the list. So when this holds a reference here, this next reference holds the location in memory to where this object exists. So when we look at this last object, its next reference is null. Okay, and that black square means null. Because there's nothing after it in the list. By definition, it's the last one on the list. So its next reference is null. Okay. Good so far? So, at this point, what I'd like to do is go ahead and start coding this stuff. We can talk about concepts a long time, and I think we can understand concepts only to a certain degree before we need to get our hands on them and start doing stuff with them by program. Okay? So let's go ahead and break here and start coding. We know what queues are. What you need to know for a queue is that the rule for adding is it goes in the back. For removing, it always gets removed from the front. Okay? And we're going to use a linked list implementation where each object holds a reference to the next one on the list. So, let's create a program. We're going to need 3 classes. First class. We need a class for the data structure. Okay, we are going to be doing a linked queue. We need a class for our data structure, linked queue. The second thing is we need a class that represents the object we're going to put in the queue. So let's say we're going to create a program where people are waiting in line to buy snow cones. We'll set that program up. What do you call someone that's waiting in line to buy snow cones? Be nice. Customer?
Yes.
Snow cone.
If that's as creative as you can get, okay. Strangers. Don't talk to people waiting in line to buy snow cones. Rules 25. We'll call them customers. The last thing that we're going to need is a driver. The driver will be our snow cone store. Now's a good time to talk about this. So, most modern languages that you guys use today, whether it's .NET based or Java, they are going to have, as a part of their API, as a part of their library of classes, these data structures created for you already. Okay. You could just import it. It would completely eliminate needing this. Okay. But the purpose of this class is to teach you a couple things. First is to expose you to the different data structures that are out there. Okay. The second is, I'll go with this first. The second is to give you an in-depth understanding of how they work and to explain the complexity and how we arrive at the complexity of adding, removing, and searching for those structures. Okay. There is nothing wrong with using the built-in structures for a language. I do it frequently. For most of the times that you'll need them, the built-in one suffices just fine. Right? There are going to be times where you need special functionality or you don't need all of the mess that comes with the default one. Okay? So I don't want you looking at us writing our own and thinking, oh, we need to write our own because the one in the languages is bad. That's not what I'm saying. Now, obviously, you can't use the built-in ones for this class. That kind of defeats the purpose. But in your own stuff, in other classes, if you're allowed, nothing wrong with using them. But it's going to make you a much better coder to be able to make your own. I'm not saying that you will need to make your own forever, but I wanted to explain why we were doing it and the difference between writing our own and the ones that come packaged with languages. Okay, any questions on that? Okay. All right, so let me kick this out of the way. Let's go ahead and get started coding. All right, so I'm opening up JGraph as soon as the projector comes up. We're done at what, 10:45? Yep. I'll make sure I stop it enough time. All right, so I'm going to go ahead and create the 3 classes. So we'll say new Java, new Java, new Java 3 times. Okay, so we've got our 3 classes down here. And then let's go ahead and write the headers for all these. We'll say public class linked queue. Is that font big enough? Can you guys see that? I can make it a little bit bigger, I think.
It would be easier. It would be.
Make sure you see it here.
Okay. So here's our linked queue.
This is going to be on.
Save this.
Okay, got it.
Make sure you're saving them all in the same location. I'm just going to save them to the desktop. All right, let's go to the next one. Here we'll put public class customer. Save it. And then we'll say public class snow cone store, which will be our driver. There's no W on snow cone, isn't there?
Yeah, there-
Without the W.
but that's the name of the store, so that's how we spell it.
Like this?
Yeah, sure.
Let's do it. We'll be spelling riddles. All right, so we'll put our main method here for our driver. So we've got our three classes. We have our queue. We have our customer objects. So we're going to create a bunch of customer objects, add them to our queue, and then we'll manage our queue from our driver. Okay? Good so far? All right, again, stop me if you've got questions. Let's start with our customer. Let's start with our customer because this is where we're probably most familiar starting off. All right? And what we want to do is we want to simply create really, really basic information that is going to allow us to visualize where these customers are inside of the queue. So we can just make sure that it's working. Again, we're not going to be doing a super fancy implementation. All of the code and all of the example projects that we make in class are simply to demonstrate how it works. And once you understand how it works, then you can do more complex stuff with it. So, let's create really simple information for the customer, like an ID, because that's all that we really need to keep track of for them. Okay, so we'll say private. We could do int. We could do string. Let's do int. And I'm going to say ID number. Okay. The other thing I'm going to do is, because we are going to use this in a linked list, we need a way for our customers to be able to reference other customer objects. So if you look here, when we've got all of these boxes, and the boxes have these arrows to other boxes, each one of these boxes is a customer. Customers reference customers. This customer holds a reference to this customer holds a reference to this customer. You can think of it like people holding hands in line. Okay, or if I said, I wanted to get this person, I can't jump straight to this person. I've got to go through the first. The first gives me a reference to the second gives me a reference to the third, and then I'm there. Okay? So that's how this works. So we need a way for our customer objects to be able to reference other customer objects. And so we're going to declare a variable inside of the customer class to be able to do that. So we've got a next reference, which holds a reference to the next customer in the list. And the data type of that reference variable is customer. Okay? Does that make sense? One customer holds a reference to another customer. Yes, sir?
So that customer, that variable has the reference number for the next one.
Correct. It doesn't have the, it has the location in memory to where it is. Okay, good. Just want to make sure we're on the same page. Alright? Constructor. When we create a customer, let's just randomize their ID. And now we could pass in what we want it to be, but let's just randomize it. All right. A couple different ways to create random numbers. Say ID number equals. First way you can create random numbers is by importing the random class and creating an object of it. You can also use math.random. Let's just do that. So math.random. So random is a static function of the math class. It gives you a number between 0.0 and 0.9999 repeating. Okay, so if we multiply this by any number, that effectively gives us a random number between 0 and that number minus 1 with decimals, which we'll cut off. Okay. So let's do a random number between 1 and 100, or 1 and 99. So if we multiply this by 100, what we're really doing is anywhere from 0.0 times 100 to 0.999 times 100. So this would obviously equal 0, and this would equal 99.9999999, right? So if we truncate the numbers, because this is an int, this gives us a random number between 0 and 99. Right? Good so far. So when we create a customer, they're going to be randomly assigned an ID, and that number is going to be from 0 to 99. Let's also create a way to set and get or retrieve the object, the customer object that this customer references. Okay, so these are simple getter, setter methods. Sometimes they're called accessor or mutator methods. We'll say public, void, set next. When we set next, we're going to accept a customer reference. And here's the thing, guys. A lot of you write this down. Feel free to do that. But I'm going to post this to Canvas as soon as we're done. Okay, so this will be right up on Canvas. I would much rather you engage and make sure that you understand what we're doing and understand why we're doing it, rather than having a duplicate of what's posted on Canvas. Okay? And again, you do whatever you want, but I wanted to let you know that this will be available for you right after class in Canvas. Okay, so if you don't understand why we put that line of code, ask. Okay. All right, so this gives us the ability to set whatever the next reference of this customer is, and we'll do the same thing to retrieve it. So we'll say public customer get next, return next. So we can set and get the next reference of this customer. Any questions? All right, the last thing that I want to put in here is a toString method. So the public string, toString, and we are going to return, we'll just return the ID. Now, will this compile? Or compile? Why not?
Because it's a string you're returning.
We say we're returning a string, but we're really returning an int. A couple solutions here. We could store the ID number as a string instead of an int. One solution. Or we could convert this to a string when we return it. What should we do? I heard a little bit about
Convert string.
Now, there are generalized rules for data types. Specifically, there are some rules for when to make something an int and when to make something a string. So should our ID number be an int or a string, really? What's the rule?
You don't do math with it, should be a string.
Typically speaking, if you don't do math with it, it should be a string. Are we going to do math with this? Probably not. So we could just change it to a string. That's probably the easiest thing to do. So how do we, changing it to a string is easy. We'll say public string ID number, but Can we put an int in a string? How do we convert it to a string? Can we do that? You can do that in Java.
Thanks, Java.
Yeah. What are the things that it just takes care of for you? That'll convert it to a string for us. We'll focus on the data structure and take shortcuts where we can. All right, so now that we've got our basic customer class set up, let's go over to our driver. And what I want to do here is I want to go ahead and create our linked queue. Okay, so we haven't done anything in our linked queue class, but I'm going to go ahead and create an object of it because we know that we're going to write the code in the linked queue class in just a minute. So I'm going to say linked queue line equals new linked queue. Now, one of the benefits to a linked version of a queue as opposed to an array is, if you look at this, is there any limit to how big this grows? No, I just keep shifting the references. Okay, so our linked queue can grow as big as we want it to. We never have to worry about running out of memory. I mean, you do, but you get the point. It would take a lot of objects to run out of memory. As opposed to an array or an array list, well, or an array, where you have to specify the size at the beginning. And if you go beyond that, it's expensive to handle that issue. Okay. So when we create our linked queue, we aren't going to pass it any sort of size, because it will automatically size itself to fit whatever it is that we put in there or take out of. And then all that I want to do after that is I want to be able to add people to the line. So I'm going to say line.inQueue. Remember, this is the method for adding. So we're going to take our linked queue object. More specifically, we are going to take the reference variable that points to or holds where our linked queue object exists. And we're going to say line.inQueue. So we're going to take that object and we're going to call the add method or the inQueue method. And we are going to pass it what? What are we going to add to the line? What do we put? What's our line made out of? Customers. We're going to create a customer object. So we can do this a couple different ways. We can say customer C1 equals new customer, and then I'll create a new customer. We can say customer C2 equals new customer. We can create a bunch of customers this way. And then C1, C2. But if you look at this, this is really redundant. Do anywhere else in the program, are we going to use C1, C2, C3? Now, what if we have like 1 billion people that work at, what if we're Walmart and we have C 8,372,000? Okay. We have tons and tons of people waiting in lines at Walmart. Selling snow goods. This is not what we would call a scalable solution. Now, if we're running a snow cone stand on the side of the road in our neighborhood, this would be okay. Because we're probably going to have like maybe one person in line. So this isn't an issue. But if we have tons and tons of people in line, this is no longer a good situation. So I'm going to delete it all. And instead what I'm going to do is say, let me comment this. Create. Add 5 customers. So we're just going to create a loop. We'll hard code it. And inside of the loop, we'll say line dot enqueue, and then instead of passing it a customer object that's already created, we'll simply say new customer. And now, let's break down this line of code real quick. We're used to seeing stuff like this. Right? This is how you guys created objects all the time in Java. And when we look at this, we went through this the other day. Right? Declaring a variable called C1. C1 can reference or hold in its memory location a customer. Okay? Now, we are assigning to memory location C1, that can hold customers, a new customer object. Which means, because we know reference variables hold locations in memory, this must give us a location in memory where a customer object exists. So if we take this and simply put it here, what we are passing to the enqueue method is a customer object. We're good with that? Yes? All right. We're simply going to call that 5 times. Yes?
Would you say that since we have an ID number made, we have like that saves us from not losing track of all the customers?
Correct.
Okay.
Yes. Now let's go over to our linked queue class. If you recall from what we wrote on the board, our linked queue keeps reference to first and last object in the list. Also, each object in the list holds a reference to the next object in the list. Now, we've already taken care of this. Each object holding a next to another customer, we took care of that in the customer class. So now we need to take care of our queue holding a reference to the first and last object in the list. So here's how we're going to do that. Say private. What is the data type of the object that's at the front and the last position in the list? Customer. Good. Customer, first, last. When we call the constructor, we'll simply set first equal to null and last equal to null. Because when the list is first created, no one's in the list. No one's in the front, no one's in the back. So they're null. You might, in situations like this, see it written like this.
Save space.
Okay. Save space. Accomplishes the same thing. Just like we declared, did comma separated declarations up above. Nothing wrong with doing it the other way, but I told you this at the beginning. I'm going to show you different ways that you might see code just to make you able to read and understand some things that are a little unusual or some things that might be a little bit more advanced. Right? So all that does is set both of them to null. Remember, assignment statements are read right to left. So null gets pointed to last. Last now holds null, which gets assigned to first. So they're both null. Then what we need an enqueue method which accepts a reference to a customer object. And we need a dequeue method, which we will handle later. Good? All right. So here's what I'd like to do. I want to stop here. The code for adding for our enqueue method is challenging, even though it's short. It's like 5 lines of code. But conceptually, it's very difficult to follow because it's a lot of reference shifting. okay? And I would like to do that when you guys are fresh, not at the very end of class, okay? When you're kind of getting to the point where you're shutting me out. And so, because this is, everything we've done so far, there's some new stuff, but we haven't done anything kind of tricky until we get here. Okay, and I want to make sure that we are on our best attention, whatever you call it, when we get to this. So we're going to pause here. We'll pick up with this next class. We'll handle NQ and DQ, how we add and remove from a queue. We'll focus that on that next class. And what I want to do with the last bit of class is I want to look at your first programming assignment. Okay, because it's actually similar to what we're doing. Okay, so let me save this, and we'll pick up with this next class. But if you go to Canvas, and then you go to Assignments, let's take a look at what we've got here. So scroll down to Programming Projects, and let me hide these other two, because you don't need to mess with them yet. Let's look at the first one, which is the queue. So you click on this, and there's two files inside of this. The top one is a Word document that is the description to do. And the second one is a customer class. You are going to create a program similar to what we're doing, more complex, but similar. And in creating that program, I'm going to supply one of the three classes that you need. Okay? For all of your programming assignments this semester, so you have two after this, I'm going to give you one of the three classes. Either the data structure, the object you're putting in the data structure, like I do here, or the driver. I will give you one of the three. Yes?
I tried accessing the document, it says it's locked. The file is currently locked.
Leslie? Oh. You are right.
You should just do all of them.
I mean, if you can do all of them, more power to you.
Oh.
All right.
But you're right. I'll go ahead and do them now. That way, we won't have that issue later. All right. So I'm going to download. I'm going to download them, and we're going to take a look at them. I'm going to try to. All right, so let's take a look at the written description first. And then we'll take a look at the customer class that is provided for you. All right, so write a program that simulates customers waiting in line at a grocery store. Similar to what we're doing. Your program must use a queue to represent the customers waiting in line. So you need to use a linked queue, very similar to what we are doing. A customer class is provided for you. You can download it from Canvas, just like I did. You must use that class without alterations for the creation of your customer objects. So if you think you're like, oh, well, I need to change the customer class like this so that my program works, you're doing it wrong. You don't need to change it. Now, you'll need to look at it. You'll need to look at the code, but you don't need to make any changes. All right? I do it like this for a reason. Okay, I supply you with a class for a reason. One of the skills that you need to develop as a programmer is the ability to work with code that exists already that you didn't write. Okay, so if you work in a team, you are picking up somebody's project that they left off, you need to be able to look at other people's code and get it to work with your code. Now, in some situations, you might be able to edit their code, but in some situations, you might not. You might be working in a system that exists already. Okay, so this is going to help develop that skill. And we're going to do it in different ways throughout the semester. Okay? You also need to create 2 additional classes. So you will create 2 classes yourself in addition to the one that's provided for you. The first will be a linked list queue that will represent the data structure for holding your customer objects. The second is a driver where your store simulation will take place. Good so far? Okay. In your driver, you're going to simulate 60 minutes of activity at the store. Each iteration of your program should represent 1 minute. So you're basically going to set up a big for loop that iterates 60 times, and the body of your program is going to be contained inside of that for loop. So each iteration represents a minute. Now, don't literally make an iteration take a minute. Really funny the first time somebody did that, but don't do that. It's going to run all at once. Okay, so you hit compile and you hit run, it's going to spit out 60 all at once. Okay, just do that. It's fun to grade when that happens. Okay, each iteration is 1 minute. At each iteration, your program should do the following. So each iteration of your for loop, it should do the following. The first, check to see if new customers are added to the queue. Okay, so does anyone show up that needs to be added to the line? There's a 25% chance that new customers show up, which means they need to be added to the queue. This does not mean you should have a customer added every 4 iterations. Rather, each iteration should have its own 25% chance. Okay, so different ways to do this. You need to generate a random number and figure out how to create a 25% chance based off of that. Again, don't do every 4 iterations added on. Each iteration has its own 25% chance that a new customer shows up. It is statistically possible that every iteration, all 60 iterations, somebody shows up. Unlikely, but possible. It's also possible that your entire simulation produces no customers. Again, not probable. What's most likely going to happen is you have a few iterations, no one shows up, and then somebody shows up, and then nobody shows up for a couple, and you might have 2 customers that show up in a row. You guys know how statistics work, okay? Questions on that? Next one. The next thing, so in addition to checking for new customers showing up, the next thing your program should do each iteration is update the customer object currently being serviced, if one exists. Okay, this will be the customer object in the front of the queue. So think about it this way. You've got 3 people waiting in line. The person in the front of the line is being checked out. Okay, they've got the groceries on the belt, and the cashier is scanning them and putting them in the bags, and it's ringing up. That's the process that they're going through when their service time is being updated. Okay, when a customer is created, and we're going to look at this in just a second, they have a service time that is randomly set for that customer. It's going to be a value from 1 to 5. So a new customer shows up here, they get added to the queue, and when they are created, they get a random service time assigned to them, which is a number between 1 and 5. That number represents the number of minutes, or iterations, that is required for them to be checked out or serviced. So someone that has a service time of 5 is represented, or represents someone that has like a ton of groceries in their cart. It's going to take them 5 minutes to be checked out. Someone that has the service time of 1 has like a pack of gum. It just takes 1 iteration and then they're done. Okay? So, we are updating the customer currently being serviced. So this is the customer in the front of the queue. Each iteration, their service time, if they're in the front of the line, gets decreased. When they reach 0, remove them from the queue. So, just so that we have a quick visual of this, if this is the front, right here, new customer shows up, the line is empty, so they go to the front, maybe their service time is a 3. Okay. Next iteration, nobody shows up. Okay, their service time drops to a 2. Next iteration, somebody shows up, their service time is 4. They go behind them. Their service time drops to 1. Next iteration, somebody shows up, their service time is a 2. Their service time drops down to a 0, and they get removed. And notice only the customer in the front of the line gets updated. If you're waiting in line, if you're one of these people back here, your service time stays still until they start checking you out. Make sense? Okay.
Okay.
All right, and then you get removed from the queue when your service time hits 0. Now, while your programming is running, you're also going to output some stuff. And these output statements indicate what's happening in your program. Okay, this serves as twofold. One, it's going to help you debug your program, and two, it's just a way of outputting what's happening. So, output whenever a new customer is added to the queue. Whenever someone gets added, you're going to say new customer added, and the queue length is now whatever the queue length is. We need to keep track of how big the queue is. All right, so when we were looking at that situation, first person showed up, said new customer added, queue length is now 1. Second person, new customer added, queue length is now 2. Okay? No. When a customer has been serviced, meaning they've been removed, output customer service to remove from the queue, queue length is now whatever the size is, after they've been removed. Okay? So if they're the only person in the queue, we say queue length is now 0. At the end of each iteration, so at the bottom of your for loop, output a bunch of lines, just dashes. This will help you see the passing of time. So you're going to see situations where there's line. That's just stuff is happening with no one's being added or removed. Okay? At the end of your program, outside of the for loop, at the very end, output the total number of customers serviced. Those are the total number of customers actually removed, and the maximum line length during the simulation. There might be customers left in the queue when your program ends. Leave them there. Don't worry about it. They have to wait until tomorrow
So you can check out.
to check out. They'll just sit in the line overnight and just wait there. Okay? But they should not be included in the total number of customers serviced. Okay? You only add to this when they get removed from the line. Okay? What questions do you have? All right, let's peek at the customer class just so you can see what's there and give you a chance to ask any questions. So again, download this from Moodle, not Moodle, Canvas. All right. So, you should not need to make any changes to this. Up in the top, you will see there are two variables. There's a service time, and there's a reference to the next customer on the list. We need this because we're creating a linked queue. The constructor next is set to null, and the service time is randomly assigned to be 1 to 5. You guys know that already. That's the code that does it. You don't need to mess with it. Now, there's a get next and a set next, which we wrote in our customer class. And there's also a get service time. You need this to be able to determine if the service time has reached 0 so that we can remove them from the queue. There's also a method that decrements the service time by 1. So the customer that's in the front of the queue, you'll need to call this method on that customer object to actually decrease their service time. And then after you do that, you can check to see if it's reached 0. This is all the functionality that you need for the customer provided here. Questions? Yes?
We're only going to be our checkout system or whatever is only going to handle one customer at a time, correct?
Correct. So, yeah. Think of it like one register. You just have one register in your store. Okay? We could create multiple queues, but that's it's a different assignment. Okay? All right, so due date.
I got a feeling that this is going to build on time.
Look at the due date.
Yeah, it'll definitely take because look at that. Priority queue. Next assignment. Yeah. That's going to go on top of this one.
Make sure you look at what the due date is on Canvas. You've got a couple weeks to do this.
Right after.
Okay?
3 days.
Everybody good? All right, hang on one second.